Hello everyone, welcome to Sir Renran's math tutorial. Before we discuss the new lesson, let me say thank you first to our new subscribers. I will do the shout outs the next video that I'll be doing. Again, thank you so much. And thank you also for being with me this time, especially learning this new lesson now as we are going to discuss it. So, welcome to our new topic of today, quadrilaterals. Okay, let's start now. What is quadrilaterals or what are quadrilaterals? Quadrilaterals are actually four-sided polygons. If you can remember, polygons are figures, closed figures that are formed by lines. And first type of polygon is the triangle or the triangles, the three-sided polygons. And here comes the four-sided polygons called quadrilaterals. There are plenty of four-sided polygons, that's why they are named as quadrilaterals, meaning a group of four-sided polygons. And this group is divided into two subgroups, parallelograms and non-parallelograms. Now, if we will say parallelograms, this include the following: rectangles, squares, rhombus, and the parallelogram without the S. Now, let's compare what is the difference between parallelograms and parallelogram without S. Parallelograms refers to the group, while the parallelogram refers to the example under parallelograms. And the other group here of quadrilaterals are the non-parallelograms. These include the trapezoids, the kites, and the other quadrilaterals just like the trapezium. And you can see the difference of these non-parallelograms to parallelograms in their illustrations or drawings. For example, as you can see here, I have rectangle below under parallelogram. We have here rhombus, and we have here a square and a parallelogram. This is how a parallelogram looks like. Alright, the rhombus seems like a tilted square, and the parallelogram is just like a tilted rectangle. All these are parallelograms. Now, in the other side are examples of non-parallelograms. We have trapezoid, this one above, and we have another trapezoid here, and another trapezoid and kite, right? If we cannot name it trapezoid, then that belongs to other quadrilaterals. There's a kind of trapezoid also that is called trapezium, and you will encounter that one in your next lessons. Okay, and that let's proceed in the following. Parallelograms are quadrilaterals with pair of opposite sides parallel. This is by definition what parallelograms are. Again, are quadrilaterals with pair of opposite sides parallel. Look at the illustration. Here is the rectangle. If you are going to extend the sides, the opposite sides, they are parallel. So there are two pairs of sides parallel in each of the example here: rectangle, square, the parallelogram, and the rhombus. Now below are some of the basic properties the parallelograms possess, like rectangle, is a parallelogram in which both pairs of opposite sides are parallel. It's obvious, that's why it's called parallelogram. The word parallelograms is from the word taken from the word parallelo, or parallel, alright, and that pertains to two pairs of sides, and this time opposite sides that are parallel. Now, a square is a rectangle. Take note, a square is a rectangle, okay, in which all its sides are congruent. Remember, a square can be a rectangle, is a rectangle, but a rectangle is not a square. Alright, again, a square is a rectangle, but a rectangle is not a square. Take note, a square has equal sides all are congruent. And then rectangle, if you're going to observe, not all sides are congruent. Only a pair of or two pairs of opposite sides are congruent. And then a rhombus is a parallelogram in which all sides are congruent, just like the square, but it looks like a tilted square. A parallelogram is a quadrilateral which both pairs of opposite sides are parallel. This is the usually all the parallelograms are represented by the parallelogram, as illustration. Usually when a teacher or someone shows an example of parallelograms, one of the parallelograms, usually what is drawn is a parallelogram. And you know what? Just to inform you that the rectangle, square, and rhombus are special parallelograms. And the parallelogram is the kind of one of the kinds in under parallelograms na we have lots of properties that we can draw. Um, there are lots of theorem that we need to study also under this one and definitions. So that means we will be studying more about parallelograms. Okay, and that the non-parallelograms, the other group, are quadrilaterals with only one pair of opposite sides, or there's none. Okay, there's none. There's one pair of opposite sides parallel, or there's none, or both pairs of opposite sides are not parallel. Look at the examples here. These three are trapezoids in different, it in different yeah shapes. It looks like shoes. This one is an isosceles trapezoid, this one is a trapezium, and this one is a kite. All right, that's why if it is not a trapezoid, then it can be called general quadrilaterals or just other quadrilaterals. Alright, let's talk about some properties of parallelograms. Usually, as I told you, when we talk about parallelograms, the usual drawing or illustration that is used is this one. Not the square, not the rectangle, not the rhombus, but this one, alright, the tilted rectangle. To represent all the kinds of parallelograms. So it's the common illustration that is used by anyone, by teachers, or if a student is going to draw parallelogram, usually it's this illustration or drawing is usually drawn. Okay, it says here these are basic properties because actually the next session, the next video will present the different properties, including the definitions and theorems, but these ones are just basic. Okay, first, in the parallelograms, the opposite sides are equal in length. That means the sides are congruent. Okay, if that's the case, that parallelogram may pertain to rhombus or square if the sides are equal. No, sides are equal. This pertains to parallelogram, the opposite sides only, right? Two pairs of opposite sides, as you can see, are equal in length. That's a parallelogram. So when it comes to square, when it comes to rhombus, not opposite sides, all sides. Okay. For number two, the opposite angles are congruent. Okay, this is very true also to parallelogram. No, the opposite angles are congruent. You see this red angle here and this one that's colored red are opposite angles and they must be congruent. They are congruent. Whatever the measure of this angle is congruent to the measure of the opposite angle. Okay, and number three, the diagonal bisect each other. Now, if you are going to draw diagonals connecting vertices, opposite vertices of the parallelogram, then you can draw two diagonals. It says that the diagonals bisect each other. That means it it divides each other equally into 2. Alright, okay. So to give us more understanding, you can just actually look into this one. The properties of parallelograms. Here is the parallelogram above, whose name is parallelogram X, Y, Z, W. Alright, you can name parallelograms using 4 letters. So you say parallelogram X, Y, Z, W following, or W, X, Y, Z following the arrangement of the letters in the alphabet. You can name it that way. Okay? It says here some properties that are just actually repeated. The opposite sides are parallel, as you see. This side here, X, W, and Y, Z are parallel to each other, and the side X, Y, and W, Z are parallel also to each other. So that's one proof that it's really a parallelogram. Another property is the opposite sides are congruent. Do you see? These sides are congruent. Their measures must be the same if you are to measure it. If there is measurement indicated. Also, these two opposite sides, okay, they must be always equal in length. In the rhombus, as you can see, here is the rhombus. There is an indication of one tick. That means all of these sides are equal in length. So congruent sides. That's true also to square. All the sides in a square are congruent. Okay, not necessary opposite, but all. All sides are congruent in both rhombus and square, but in a parallelogram, opposite sides are congruent. It's true also to rectangle. Opposite sides of a rectangle are congruent, just like the length and then the width. Okay, I think that's it for this topic. Very simple, right? I'd like to say thank you for watching, and bye bye.